Now see how can we solve this. In this question we want to calculate the potential difference across P and Q. Means we need to calculate VPQ, right? We'll move from P to A to B and B to Q. So we can write down VPA plus VAB plus VBQ, correct? Because it is moving from P to Q. As you can see that there is no direct connection between P to Q, so we have to follow this path, or you can follow the long path, but there is no use, right? So VPA is how much? That is IPA multiplied by RPA. VAB will write down as it is because they have mentioned voltage, that is 5. VBQ is how much? Again IBQ into RBQ. So IPA, we are flowing from P to A, right? So current should also flowing from P to A only. So their sign is positive, their sign is, here sign is negative, right? This one is negative, this one is positive. Now we are moving from B to Q, so our current should also move from B to Q only, that is IBQ. Here it is positive and here it is negative. So either we need to take all the second sign or we need to take all the first sign. We are moving from P to A. What is the second sign? That is negative, correct? We are moving from A to B. That what is the second sign? That is positive. We are moving from B to Q. What is the second sign? That is negative. So we'll write it according to that only. Clear? RPA value we know that is 3, and RBQ value also we know that is 2, but we don't know the value of IPA and IBQ. That will get from the equation. As you can see, this is a mesh, so from this we'll get plus 2 minus 3 IPA minus 5 IPA is equal to 0. From here we'll get the value of IPA. Similarly, we'll apply KVL in mesh 2, that is minus 10 minus 3 IBQ minus 2 IBQ is equal to 0, right? If we'll solve it, we'll get IBQ is equal to, that is 5 divided by 10, that is minus only, minus 2. And if we'll solve it, then we'll get IPA would be equal to 8 divided by 2, that is 4, right? So here it is 4 ampere and here it is minus 2, so we'll write down minus 2 only. So we can solve it further, then we'll get the value of VPQ. Clear?